bucka. Ha. You know the deal.
The next thing we're going to talk about in our geometry unit is what's called rotations. Now, if you think of a rotation or a turning motion, what probably comes to mind is a circle. And when we're doing a turn, if we're turning in a car or on a bike, really if you're turning, you're turning on part of a circle. And if you do a full turn, you make the shape of a whole circle. So when we're doing a rotation, it is based on a circle. And the first thing we have to know is where is the center of the circle. So once we know where the center of our circle is, the next question we have to ask ourselves is, well, how many degrees of a turn are we going to do, and what direction are we going to go? So suppose for this example, we're going to go 90 degrees clockwise. So just like with reflections, what that means is we have to turn every point on this shape 90 degrees clockwise around that center there. But also, just like with reflections, we're going to focus on the vertices. So first we're going to draw a line or lines that are only at 90 degree angles from the center of the circle to one of the vertices. So I'll do that there. And now what I want to do is I want to turn that 90 degrees, and clockwise means the way a clock would go, the direction a clock would go. So 90 degrees would be a quarter of the circle, and clockwise would be this way. So we want to take that vertex and turn it so that it's there. So when you're doing a rotation, one way that can be helpful to think of it is, if you think of the center as the center of a propeller on a plane, and we draw lines from the center to each vertex only using 90 degree angles, and I'm going to explain a little bit more what that means in a second. So from the center here we can see that this is a 90 degree angle, and we turn the propeller of that blade 90 degrees clockwise in this case. So this vertex ends up here. So if this is our original vertex, after a 90 degree turn clockwise, where this is the center, our translated vertex, or our rotated vertex, ends up here. So we'll call that A prime. Now for the next vertex here, because I want to make a turn that's 90 degrees, if I just draw a straight line from the center of the circle to the edge there, it's a little bit hard to tell where that will end up if I turn it 90 degrees. It's hard to turn that a propeller that's shaped in that way 90 degrees. So instead, I'm going to draw a propeller that only uses horizontal or vertical lines. So we can go horizontally there and vertically there. So again, you imagine that this is the center of a propeller, and now this sort of L-shaped drawing here is our propeller, and we're going to turn that whole shape 90 degrees clockwise. So a quarter of a turn clockwise. And so when we do that, we can see the propeller ends up looking something like this. So we took that propeller and turned it, and this vertex ends up over here. So if this was our original vertex called B, when we rotated it 90 degrees clockwise, it ended up there. So let's look at the last vertex, which is up here. And again, I'm going to draw a propeller from the center of our circle to that point, only using horizontal and vertical lines. So now you can see I've drawn the blade of the propeller. It's in green. From the center of the propeller, and again it's L-shaped. You can see the green lines, and we're going to take that blade of the propeller and now turn it 90 degrees clockwise. And when we do that, that propeller ends up there. So this vertex, when turned 90 degrees clockwise, where this is the center, ends up over here. So if our original vertex here is C, after we turn it 90 degrees clockwise, where this is the center, that vertex ends up there, and that vertex is C prime. So now we can see our rotated image. If we join our vertices A prime, B prime, and C prime together, our rotated image ends up looking something like that. And again, each one of these vertices was turned 90 degrees clockwise. About the center that was given.
For the next example, we're going to look at a shape where we're rotating 180 degrees about the origin. So what that means is the center of our circle is where the two axes meet, where the x-axis and the y-axis meet. So at that point right there, that's the center of our circle. So once again, we have to kind of draw these blades of a propeller from the center of that circle to each of the vertices, and we only want to use horizontal and vertical lines. One thing you'll notice is I didn't say which direction we're turning, and I'm going to talk about why that is in a second. So here I've drawn that first blade of the propeller, and so it starts at the center of the circle, which is at the origin here, and I've only used horizontal and vertical lines. So now we're going to turn that blade 180 degrees, which is a half a turn. And when we have a half a turn, it doesn't matter if we go clockwise, a half a turn, or counterclockwise, a half a turn. Either way, you end up at the same point. So if we turn that blade 180 degrees, a half a turn, it ends up looking something like this. So now you can see I've taken that blade and turned it half a turn, 180 degrees. So this vertex ended up over here. So here again I've used only horizontal and vertical lines to draw that blade from the center of the circle to the next vertex. And I'm going to take that blade and I have to turn it half a turn, so 180 degrees. And so now we can see that this part of the blade turns to there, and then that means that this piece will be now facing down. So this vertex ends up over here. Once again, here I've drawn that blade only using horizontal and vertical lines to go from the origin to this vertex here. And if we turn that blade 180 degrees, I know that this line is going to go here, and this line is going to end up facing downwards over here. So this vertex ends up here. So if I continue to do that with each vertex, what we find is that when we rotate this shape 180 degrees about the origin, so that means the center of the circle is at the origin where the two axes meet, the shape ends up rotated over here. So we've now turned this shape a half a turn from here to here. So to finish off our lesson on rotations, I'm going to ask you to do a couple of things. So the first here is to take the shape that we have here and rotate it 180 degrees about the origin. So the center of the circle is where the two vertices meet. Next, rotate the same shape 90 degrees counterclockwise about the coordinate 1, 3. So the coordinate 1, 3 would be here. and that's the center of our circle now. I'm going to actually show you what your shape should look like when you do that. So when you rotate 180 degrees about the origin, it should end up looking something like this. So that should be your rotated shape there. When you rotate it 90 degrees counterclockwise, about the coordinate 1, 3, it should end up looking something like this. So if you were able to do that, congratulations, you now have a firm understanding of rotations.